right, guys, we are starting geometry, one of my favorite units. Before we start, we're going to just do some basics, some of the things that you should have done in previous years, but you might just need a little bit of review. So let's go ahead and get started. You should have your notes on your desk, and you're going to have to fill in some certain things, okay? So let's look at just the basics, a line, a point, ray, and a segment. So a point is just a single dot. It's just a single exact location on a line, array, or a segment. Okay, so it just looks like that. A ray, oh sorry, a line. A line extends forever in both directions. Okay. You know that a line extends forever because it has those arrows on both sides. Okay. The way that I identify a line, or any of these actually, I have to use the symbol and letters that are on the line, the ray, or the segment. So in this case, if I see my line, the symbol for a line is just a line with arrows on it, and I choose two letters on the line. In this case, I only have two letters shown, so it's just line AB. That's how I identify it. I could have also done the other way, line BA. So you always need the symbol and then two letters identifying it. Okay. The next one is array. Array extends forever in one direction. So if you see my example, you notice that it kind of starts at X here and it goes forever in the Y direction. Okay. So again, the way that I identify this is I have a ray. This is my symbol for array. And I choose two letters on the ray. The only thing different with this one is you got to make sure that this endpoint has to be the same on this side, X, Y. Okay, you couldn't say this, Y, X. You couldn't say YX because Y is not the endpoint and it's not going forever in the X direction. Okay, it's not going forever that way. So that one doesn't work. You could say this if you wanted. You could say it's ray X, Y because the endpoint is still here, okay? And then a segment is just a piece of a line. Ooh, if I could spell that right. Hello. Lost my eye there. Okay. There you go. Okay. All right. So it's just a piece of a line. So if I wanted to write this, the symbol for a line is just a line. Sorry, the symbol for a segment is just a line, no arrows on top, and then two letters. Okay? All right, so let's look at this next part. You don't have this on your notes, but I'm going to just give you a little bit more. I think sometimes a line can be a little confusing. So if you look at this, this is clearly a line because it has arrows on both sides. So I can identify this line, AB, or sorry, AD, line, how about BC, line, CD, a lot of these. I just choose two letters, doesn't matter. But here's the tricky part. Within that line, there are also rays and there are also segments. Okay, there are also parts of it. So if I wanted to identify a ray, I could say, use my symbol, ray, let's say BC. Okay, if I look at ray BC, I go to it and it means that I start here and I go forever in this direction. Does ray BC include the point D? Let's go back up and look. If I start here and I go forever this direction, yes. But does ray BC include the point A? If I start here and go forever this direction, no, it's not including point A. Okay. Let's say if I said ray, let's go CD. Ray CD, that means it goes from here to here. That means it does not include either point A or B. Okay, so within that line there are rays within there. There are also segments. So if I wanted to say segment AC, does segment AC include the point D? No, it doesn't, because it just goes from here to here, and that is it. But does it include the point B? Yes, it's right in the middle. Okay, so that's why it's so important that you put the symbol on top, because if you just said AC, I don't know what you're talking about. I don't know if you mean a line AC, if you mean ray AC, or segment. So you have to put the symbol on top, okay? All right, you're going to have some practice on that later, but let's move on. All right, the next one is an angle. This is on your notes now. An angle is formed by two rays with the same endpoint. Okay, so if you see my ray here, together, if they have that same endpoint, they are considered an angle. Okay, this point right here is called a vertex. Okay, it's where the two angles meet, or the two rays meet. That is a vertex. So if I wanted you to put arrows here, if I wanted you to identify this angle, you could identify it three different ways. Okay, you can, first of all, we need to use the symbol, which is, this is my symbol for angle, that right there. I'm going to use three letters. I'm going to use the three letters that are on my angle. So C, B, A, C, B, A, or I could say angle A, B, C, A, B, C. Okay? Using three letters. Now, sometimes if you only have one angle shown, you could also just use the vertex. So angle B. Okay? But that one doesn't always work, because if you look down here, do you notice that there's more than one angle? So if I said angle U, I wouldn't know if you were looking at this angle. I wouldn't know if you were looking at this angle or if you were looking at this one. So that's why you would have to use three different letters. Okay? All right, again, you're going to do a little bit more practice. If you have some questions on that, make sure and let me know. All right. All right, next part, looking at your angles. I want you to see if you can identify the names of these angles. Okay, so I want you to read the definition and then write down if you know the name of them. The first three you should know for sure. The last four, not so sure. Okay, so go ahead and pause the video and write down what you know. If you don't know them, that's fine. We'll talk about it. So go ahead and pause the video and come back when you have the answers in. All right, let's look at that first one. An angle measuring less between 0 and 90 degrees, that is a acute angle, an acute angle. Okay, I always call it, it's a cute little angle. Okay, it helps me remember it. Okay, an angle that measures exactly 90 degrees is a right. Okay, it looks like an L, it's a right angle. An angle that measures between 90 and 180, that's obtuse. That's like an obese angle, it's big. Okay. Now, these you may not know. An angle that measures exactly 90 degrees, well, isn't that, hello, just a straight line? Yes. So that is a straight angle. Okay, it's a straight angle. All right, these three you probably don't know. A vertical angle. It's where your opposite angles are formed by intersecting lines. Basically, what that means is this angle right here and this angle right here, because they're opposite of each other, they're called vertical angles. So I could call this angle 1 and angle 2. So angle 1 and 2, because they are vertical angles, it just means that their measurement is the exact same. So if I were to tell you that this is 40 degrees, then this one would also be 40 degrees. Okay? All right, next one. Two angles whose measurement add up to exactly 90 degrees. That's called a complementary angle. Okay? Two angles. Do you see this 90-degree angle right here? Okay. If this one were, let's see, this one is, well, this one looks like 45. Then 45 plus 45 equals 90. Okay. So let's say here's another one. Let's say if this one were a 30-degree angle. Oh, you can't see that at all. Let me try it bigger. Let's see. Ooh, doesn't look really 90, but if this is a 30-degree angle, then 30 plus what has to equal 90? Because we know this is a 90-degree angle. That would be 60. Those two together add up to 90. Okay. And the last one, a supplementary angle, are two angles that add up to 180 degrees. So do you notice that this is a straight line, okay, which adds up to, right up here, 180 degrees. If I were to cut that angle into two separate angles, if I told you that this one right here was 70 degrees, then you should be able to tell me what this one equals, because 70 plus what is going to give me 180. 110. Okay, because those two together have to add up to 180. Okay? All right. All right, let's look at your angles. Again, I want you to pause the video. I want you to write down what you think these are. If I were going to classify angles, classify triangles by my angles, what would they be? Okay, so that's, and then this one, if you were going to classify triangles just looking at their sides, the lengths of their sides. Okay, pause the video and come back. You should know them, even if um, you should know these. After I give you the answer, you might think, oh yeah, I remember that. Okay, so pause the video and write down what you think. All right, so looking at their angles, a triangle that has 3 acute angles is simply an acute triangle, okay? Do you notice here how these angles are all really small? They're all less than 90 degrees, okay? One right angle, that is a right triangle. They will normally show you that it has a right angle by a little square there, okay? And one obtuse angle, just one obtuse. You could only have one obtuse. You wouldn't be able to have two obtuse angles. It wouldn't come together. So that is considered an obtuse triangle. Okay? Is this all sounding familiar again? Okay. These are the ones that are a little bit harder. So we're looking at their sides. So something that has all different lengths. Do you notice all those lengths are all different? This is called a scalene. Oops, did I forget that one? Oh, hold on. That is a scalene triangle, okay? Has two sides the same length. That is, where to go? Oops, nope, come on. Isosceles, okay? An isosceles triangle has two sides the same. And the last one, an equilateral, has all three the same. Okay, the way that I think of this, equilateral, obviously, that's easy. Equal, they're all equal lengths. An isosceles, I hear the word I in there. I hear the word I, and I know we have two I's, so two sides the same. And scalene, no matter, people get on the scale and they weigh different, so it's all different. People get on the scale and they're different. That's how I remember it. Okay, it helps me. Okay. And the last thing you need to write down, a triangle, all of the angles within the triangle need to add up to 180 degrees. So if I have a triangle and I give you two, that's going to be equal. Hold on. Let me do better. Let's see. Yep, let's look at that one. Let's say I say this is 60 and this is 70. I don't know. I'm making this up, kids. Those two together, if I give you those two, you should be able to tell me what this one measures, okay? Because everything adds up to 180. So 60 plus 70 is 130 degrees. 180 minus 130 is 50. So this should be 50 degrees, okay? Okie dokie. All right, now you've got 7 problems to practice, okay? I want you to read through the notes you just did, and I want you to go through and I want you to label what these triangles are, okay? There is room on the bottom of your paper. Pause the video and come back with your answers. All right, check those answers. Hopefully you didn't have any problems with those. If you're having problems with that review, please let us know, okay? All right, last thing, quadrilaterals. Okay, remember a quadrilateral is a 4-sided shape. Okay, it has 4 sides to it. We have a lot of different types of quadrilaterals. So here are 5 different quadrilaterals. I want you to see if you can write down the names of those. Read the definitions, look at the picture, see if you know the names of them. Pause the video and come back with your answers. All right, only one pair of parallel lines. Here are my parallel lines. Parallel lines are lines that never meet. So this line and this line are parallel. So one pair of parallel lines, that's a trapezoid. Okay. A quadrilateral with 2 pairs. This one is parallel to this one. And normally they will show you that they are the same. This one is parallel to this one, and this one is parallel to this one. That's a parallelogram. Okay. The next one, this is actually a parallelogram. Parallelogram. I didn't put that on there. It's a parallelogram with 4 right angles. That's a rectangle. Okay. All of these are now parallelograms. All the rest of these are parallelograms because they all have 2 pairs of parallel lines. A parallelogram with 4 equal sides, that's a rhombus. And then a parallelogram with 4 right angles and 4 equal sides is a square. Okay. And last thing there, an angle, the angles within the parallelogram should all add up to 360. Okay. So for example, on this square, 90-degree angles, there are 4 90-degree angles. Those are all 90. So 90, 90, 90, 90, that equals 360. Okay. All right, last part. All right, congruent and similar. Okay, I went ahead and wrote down the definitions and everything for you. But just so you know, congruent means it is the exact same shape. It is the exact same thing here. If you look at this, this is the exact same. The only thing different is this one has been rotated. Okay, it's been rotated, but look, it's the exact same. Okay, so with the congruent, they've normally been flipped, they've been rotated or turned, but they are the exact same. Similar. If you look, aren't these similar shapes? Yes, they're similar shapes. However, they're different size. The lengths are different size, but they are proportional. So if you look at this one, it is proportional. Like this one is probably twice as much as this one. Okay. So if I were to give you something, let's say if I said that this was 5 inches and this one was 10 inches, do you see how much greater this one is? That's multiplying by 2, right? So if I said this was 4, wouldn't you be able to tell me what this is? Multiply by 2, that would give you 8. Okay? So that's congruent and similar. All right. I tried to be short, kids. I really did. I promise you. But we did need to review that stuff because I wanted to make sure you had that. So anyway, you've got a quick worksheet with you. So hope you have a great day. If you had any problems with that, let us know. Have a great day, kids.